So I think working in R is a lot of fun. I enjoy writing R code. It's very expressive. But as Julie was saying, the fun kind of runs out when your data starts getting bigger. And it's because, like she was saying, R needs to hold everything into memory to work on it. But when you run out of memory, I guess that's the fifth one in the meme would be explosion. So I'm going to talk about the Arrow project. And in particular, I'm going to use a lot of examples from the Arrow R package. I'm one of the co-creators of that. Has anyone used Arrow before? Anyone at the workshop on Friday who was talking Arrow DuckDB? Cool, cool. But Arrow is actually much more than an R package. It is an open standard for how to represent data efficiently in memory. And there's a large community-maintained project that defines that standard and implementations in over a dozen languages. And all of the tools that are getting built these days for analytics, query engines like DuckDB and stuff are being built on top of this specification. So I'm going to talk about things in the Arrow package, but I'm also going to talk about a lot of things that are related, like Parquet and DuckDB. Just as a motivating example, I've got some census data here from the public use microdata sample over many years. And the CSVs that you download are 45 gigabytes. I estimated that it would be 80 gigabytes if I read it all into memory, but I don't have 80 gigabytes here, so I can't. But using Arrow, we can query it. And similar to how Julia was describing, I don't actually have to read everything to memory. And so I can answer the question of how many people took the subway to work in 2021 and see that it was about 1.5 million, and I get that answer in 150 milliseconds. So I'm going to talk about three reasons why this works and three things you can take away to build on this. And the first is Parquet files and what makes them special, what makes them different from other formats. And second, how you can chunk your data into meaningful partitions or lots of files that help optimize the queries that you make. And then I will talk about query engines. I'll talk about the one that's in Arrow, and I'll also talk a bit about DuckDB and how you could use them together. If any of this sounds interesting to you, you're in luck. There is an entire book about this co-authored with Nick Crane and Jonathan Keene. There's a copy of it upstairs if you want to page through it, and a discount code there of 20% off at that link. I'm going to have some QR codes on the slides throughout that link to different parts of the book in the website form, which is also available and costs nothing. It's at arrowrbook.com. So if you prefer the form factor of something you can hold in your hand, please go buy it. If you want to look at it online, that's fine. Maybe you could donate to your favorite charity. Here, the R Foundation is looking for donations instead. Okay, let's talk about Parquet files. So I said that Arrow is a specification, is a standard for how to represent data in memory. And Parquet is analogously, it's an open community-supported standard for storing data on disk. And there's differences of why, there are different choices that you would want to make for how you represent in memory versus disk. And I'll talk about that in a second. To your question, Feather was an initial kind of prototype implementation of the Arrow in memory format. So you can totally use that. You can write Arrow memory straight to disk too. But Parquet files are generally going to be smaller and a little bit faster to query for a few reasons I'll talk about. This is not just an R thing or a Python thing. Most of your big data systems are going to deal in Parquet files. There's entire startup billions of dollars built on top of being able to work with Parquet files. So it's wide adoption, implementation in lots of languages. Like the talk in here before lunch, it's a great choice for interoperability across languages, but it also has some really nice properties, even if you're just in R. So to explain a little bit what's different about it, the first thing to note is that Parquet is columnar, unlike CSV where each line of text is the rows. And that's important for a few reasons. One, it's what R does anyway. That's how Arrow works as well. And so the amount of translation you have to do to read a file that's on disk into memory is much lower. But being columnar gives us a few other advantages too. So like Julie was talking about, we can work with Parquet data and only choose to read in the columns that we actually need for analysis. If the census data files I was talking about have 311 columns, I'm never going to do an analysis that requires like reading all of them in at once. The one I chose, I think, used 2 columns. And so why read in 309 other columns if I'm just going to throw them away? So that's one way. And also, and this is more of a technical implementation thing, if you store data that's the same type close to each other, you can compress better. Compression algorithms are designed for that, as well as various encoding schemes that are part of the Parquet specification. Speaking of data types and stuff, Parquet has a rich type system. It's richer than R's data type system. In particular, it has support for nested types and complex types. Imagine trying to represent a list column type of thing in a CSV. Like it's not something you can do. And because you can represent that type system, those types in the file itself, you don't have to guess them when you read them back in, which is inefficient and loses information, right? So in some, Parquet files are high fidelity. When you write it to disk and read it back in, you get the same thing. And you get smaller file sizes, and they're faster to read in, too. All right. Very easy to read and write Parquet files. The Arrow package has read Parquet and write Parquet. There's options to go with that. But as Julia said, there's also Nano Parquet if you just need to read the file in or write a file. To contrast a little bit, Nano Parquet is tiny. The Arrow package is much larger. Arrow comes with a lot of other stuff in it. And if you don't need that, then you don't need that. You may encounter, depending on how widely you're plugged into like the bleeding edge of the Parquet ecosystem, features in Parquet files that Nano Parquet can't read because it is an evolving standard. And the Arrow package includes the kind of official C++ implementation of the Parquet library. So you're more, if you're on those edge cases there, Arrow is more likely to work for you. But for most other things, Nano Parquet is a great choice. Okay, so I talked about Parquet files, and next is, well, I don't want just one Parquet file, I want many files. And so the data set that I use that example of initially is actually split into 884 files. And if we look at the path segments of this, it's nested in a couple of different directories. And as you can see here, this is just the first 10 files in there. The first one is saying year equals 2005, and then location equals, and then it's state codes and stuff like that. This is what's known in the industry as Hive-style partitioning. It's from the Apache Hive project. It's part of the Hadoop ecosystem. And so both the name and the value of these columns is encoded in the file paths. And why does that matter? So that matters because I can actually just look at the file path, like the file name, and know whether or not I need to read it in if I'm filtering or something on one of these columns. So, this allows us to just skip those kinds of files. And you'll see this in local files or in cloud storage as well. And so, in the example from before, I didn't have to scan 884 files to answer it. I could see that I only need to scan 52. If you have data and you want to partition it, or it's already partitioned and you want to partition it differently, the Arrow package has a convenient write dataset function. So you can pass it either a reference to a directory of files or a reference to just a single file. Like I could have this CSV, I could have a 45 gigabyte CSV that I can't read in, and I can still address it in this way. It's not going to read everything in, it's going to chunk over it, and I can split it into things that I can either read the whole chunk in memory and do something that way, or I can query it in this way as a whole. The question that I am most likely to get when I talk about this is, what's the best way to partition? Anyone know the answer? Yes, there it is. It depends. That's right. So if I know that I'm going to filter, do queries by year, then great. You should do that by year. It's not. You could take that to the logical extreme though and say, well, I'll just partition by everything. It'd be great. And so you need to watch out for the number of unique values that you have in the column, because if you get too many partitions, it's too many files, and so Each file you read has some overhead. And also you just lose the benefits of having a columnar format because essentially you've turned it back into rows, right? This QR code here points at the chapter in the book. I don't know if that's a little blurry or not, but in the book we have a whole analysis and put some numbers behind this too. Okay, so the third thing is query engines. Julia was talking about DuckDB's query engine, and the way I think about how to understand what a query engine is, if you take a database, and are there any CS professors in here? I'm overly reducing things here, but I think of a database as just a query engine on top of storage. It's storage that it owns or whatever. And so you're connecting to a service that's across the network or whatever, and it owns the storage. There's no other way for me to get at it. But what DuckDB does and what the engine in Arrow does as well is we're basically just separating the query engine from the storage. And I can say the storage is it's the files on my file system. And so in that world, I don't need to have a database that's running all the time that I then authenticate to and point to. I just start up an R process and I load a package. And so essentially my R process becomes the front end to my data store that way. And as Julia was talking about, lazy evaluation is important. And in the dplyr sense, if I'm writing SQL, I write the whole SQL statement and it's all there. That's the full query. But dplyr, I'm essentially, with each statement, I am building up a query. And so by not evaluating until I hit the collect verb there, that allows us to do some analysis and decide I don't need to read in all 884 files. I only need 52 files. I don't need all 311 columns. I only need JWT, RNS, and PWGTP, of course, because those are the only ones that are actually in the analysis. And so the lazy evaluation from the dplyr side allows us to build up this query and make some optimizations. And that's what query engines are designed to enable us to do. So the Arrow package, the query engine that you get within the Arrow package has great dplyr support. We invested a lot to support not only the functions in dplyr or base R, but we also added a lot of support for string R functions and lubridate, to make it very natural for you to do this. And the way it works is, I can even say I'm calling string R, explicitly, and what the code is going to do is it's going to map that and any of the options that the functions have to the the C++ functions basically that are getting called in the engine. So we've added those mappings for over 200 functions. There's more there. There's a bunch of, I said we've got great support for string R in the Arrow package, but there's a bunch of other string functions that are in the Arrow library that are, is this ASCII, is this UTF, all sorts of things that don't have a direct analog to something in R. And you can call those directly too. You can also write your own functions, user-defined functions, and it will run R code inside the query engine if there's something that is specialized there. The package documentation has an up-to-date list all the time of what things are supported and what caveats there are. The question I usually get here is, should I use Arrow or DuckDB? What's the answer? Yes, you should. You should. I think for most things, either one's just fine, right? There's going to be some things that one or the other does better. If I'm being honest, DuckDB is going to do probably more things better on that side of things. Their database, the people who write DuckDB are database professors. They know things. We know things too. The people that work on Arrow know a lot of things. I think historically Arrow has had much better dplyr support. So it's more of an ergonomic question, I think. I think personally, I'm more, when I see the code that I have to write to do certain things in DuckDB, I understand it, but it's not as intuitive to me, but that's just me. But to get the work done, either are generally going to be a good choice. But the real question is, why don't we have both? And there's some cases where this is actually really helpful. And the way that this is enabled is this Arrow memory format that I was talking about. So they're able to pass references to memory, and so I can basically stream batches of data from one engine to the other And it's not copying the memory, it's not writing anything to disk, it's not translating anything, because it's the same internal memory structure. And so it's super efficient. In the Arrow package, there is a to_DuckDB function and then a to_Arrow function. So I can do certain things in Arrow. I like, for example, how the open dataset syntax in the Arrow package, to my mind, that's a lot easier, but maybe it's because I wrote it. It's like setting up and specifying the partitions on those things. I find that a lot more intuitive to me. And so I can use that, and then I can run queries in DuckDB. Performance is generally going to be good enough either way. There's going to be certain things that are more optimized in one place or the other. In this example here, there's a pivoting function in DuckDB that is not in Arrow, and so you can just hop it over there and do that. You can find cases where there's something that's only supported in Arrow and something that's only supported in DuckDB. Arrow's got support for the package. You just download the package, and it's going to come with AWS S3 support, Google Cloud Storage, and as of today, I'm sure Hannes will watch this and like go make the Google Cloud integration. But as of today, they don't have a extension for Google Cloud Storage. So if you had data in Google Cloud, you could open the data set using Arrow, and then you could just write SQL even if that was your thing, using DuckDB. Okay, so if I leave you with nothing else, Parquet files are really good, and you should use them. We can get a lot of benefits for querying larger data by splitting our data into multiple files, preferably meaningfully on partitions, and then using a modern query engine. And it's great. These packages, they give you like all of the state-of-the-art of analytic database technology, and you just install it from CRAN. Like it's really we live in wonderful times, at least in this area. The Arrow package, I will acknowledge, is a large package. Comes with a lot of stuff. If you just need pieces of it, you can get pieces of it from other places. I mentioned Nano Parquet. There's also a Nano Arrow, which is probably more useful if you're building libraries that connect to other services that emit Arrow data, but it helps you get data to and from the Arrow format. And really, Arrow is what holds all of this together. And so whether or not you use the Arrow package, if you're dealing with larger data these days, you're using Arrow somewhere in there. That's what helps us get these efficiencies across these systems. Here's a bunch of QR codes here that go to different places. These slides, some package documentation, both back to the book website or to where you can order it, a physical copy and discount code. And that's it. Thank you very much.